next presentation, I would like to call upon stage Miss Varnika Agarwal, Battery Research Analyst, RoMotion. The topic of presentation is Battery Technology Roadmaps, the influence of current and emerging technologies in India. Over to you, Varnika. All the best. The stage is all yours. Thank you so much.
Thank you so much for having me here. Am I audible? Okay. Thank you so much for having me here. I'm Varnika Agarwal, Battery Research Analyst at RoMotion. Today, I'm going to talk about EV battery deployment globally, then looking more closely at the Indian market, which will be followed by a discussion on emerging technology with a focus on solid-state battery. Before I get to the main talk, I'm going to give a brief introduction about RoMotion. RoMotion is a London-based research house which looks at the 6 key areas of energy transition. We look at EV and battery, motor system, stationary storage, recycling, charging and infrastructure, and a wider energy mix, which help us to give our market analysis with the impacts in terms of legislation, the disruptive technology. This is provided through 3 key platforms. One is membership, in which we have publications and quarterly reports. The second is the consulting, and third, we host a number of events. So that's all from me on the company side. Now talking about the EV battery deployment. So globally, if we look at the total battery deployment, looking at 2020, we saw around 0.3 terawatt deployment. Out of that 0.3, 50% battery demand was coming up from the EV sector. Now looking at 2024, we saw around 71% EV deployment, and now it's reaching around 1.2 terawatt mark. Now we are in India, and looking at the Indian market, if we look back at 2020, most of the battery demand was coming from portables, with electric vehicles being negligible. But now looking at 2024, we have seen this trend to be changing. We are seeing around 35% battery demand, Indian battery demand, coming from portables. 2 and 3 wheelers has really come up, and we are seeing around 27%, and we expect this to be growing in coming years. And now electric vehicle market and stationary storage has started to take place. Now looking more closely at the cathode chemistry and their mix. Globally, we are looking around 44% LFP share. This is majorly driven by China, where we're seeing around 67 to 70% LFP deployment. And in coming years, we expect that this percentage share would remain same. Looking at the other key markets, in the US and Canada, we see around 8 to 9% LFP deployment. This was majorly driven by Tesla announcing some LFP models last year. However, with the addition of Inflation Reduction Act and additional tariffs in the US and Canada market, we might expect this to change. However, we are seeing very low prices of LFP in the market, which leads to maybe we will still see US LFP increasing in US and Canada. In Europe, we see low demand of LFP. This is majorly due to lack of support from the OEMs. However, now traditional NCM players like Samsung, LGS, and others mentioned over here have started to announce LFP capacities. So by 2026, we expect that the LFP global share outside of China will start to increase. And by 2030, we expect that it will cross the 1 terawatt mark. Now talking about battery technologies, lithium-ion battery technology has been majorly driven because due to the electric vehicle space, how there's a constant need for increasing the energy density to overcome the range anxiety issue that the consumer has. This has led to increase in advancements in cathode chemistry. Initially, there were NCM 11, mid-nickel chemistries, and now we are seeing NCM 811 being deployed. There were reports of companies exploring NCM 9.5.5. However, now the theoretical limit for the cathode chemistries is reaching. So now there's a need for material development on the anode side or newer chemistries. Talking about anode, graphite is the traditional anode material, which has a specific capacity of around 372 milliamp per gram, whereas lithium metal and silicon is almost 10 times the specific capacity of graphite. What that really means that your energy density could increase if we use these materials. There's a lot of interest in graphite plus silicon blending, lithium metal, solid state. Talking about solid state, if we talk in terms of energy density, if we and compare it to traditional lithium ion battery, we expect around 50% increase in energy density. What is a solid state battery? A solid state battery is made up of several components: your anode active material, anolyte, separator, catholyte, and cathode active material. And the combination used will determine your energy density in the end. Not talking about the components, it can be divided into semi-solid state batteries and all solid state batteries. It is very important to understand the difference between them. In my previous slide, I discussed about anolyte and catholyte. If there's a liquid in that, you have a semi-solid state battery. In a semi-solid state battery, you have your liquid components with a solid electrolyte. But because of that solid electrolyte, it can help in increasing the energy density and your safety. But it will help in increased wettability. And it can be easily incorporated in the already established gigafactories in the value chain. However, due to the presence of additional liquid, it increased the weight of the overall battery, which compromises the energy density increase as you would have expected. We are starting to see some of semi-solid state development. Recently in China, NIO announced a semi-solid state pack in collaboration with B-Lion. Moreover, IM Motors in China announced a 130 kilowatt hour pack again in China for mass production. Now, talking about all solid state battery, in an all solid state battery, all the components are solid. That helps in giving you higher energy density, higher safety, more cycle life performance. However, because all the components are solid, there is an insufficient contact between your solid electrolyte and your cathode and anode active material, which leads to your complex fabrication process. Till date, there's no all solid state battery in production. Anode-less solid state battery configuration is becoming popular. It can be a semi-solid state or an all solid state battery. Companies like QuantumScape and Samsung SDI are trying to commercialize those configurations. I just mentioned about solid electrolyte being a very important component of solid state batteries. There are three main solid electrolytes: oxides, sulfides, polymers. They all come with their own set of advantages and disadvantages. In this table, I have compared the traditional cathode and anode material against these parameters, and they are compared for an uncoated cathode active materials and anode active materials for simplicity. As you can see, each have their advantages and disadvantages, but the key message is polymers are easier to incorporate, but due to being less mechanically strong, your lithium penetration can happen and fail. So we need a combination or a hybrid. Oxides are brittle, but have higher electrochemical compatibility. Sulfides seem to be more the way for all solid state batteries. As I mentioned, there are so many benefits to us all solid state battery, but they're still far away from commercialization. The challenges associated with them are low cycle life due to all the components being solid and having an insufficient contacts that leads to low life performance. Scaling up is another challenge, as right now there is no one chemistry that fits the all solid state background. So we need to change the existing manufacturing lines, which will lead to additional capex requirements, making it a hurdle for commercialization of an all solid state battery. The third is cost. As I mentioned, the cost is an important factor. We don't expect all solid state battery to be cost competitive in near term. We are looking at mass production somewhere around 2030, And to be cost competitive, you're looking around after 2035, most probably, just because of the challenges. Material composition is another issue, as there's sulfides, oxides, polymers, so there's no one chemistry that is fitting. And a lot of companies are doing their in-house research, which makes it difficult for equipment manufacturers to have one particular equipment for that process. Apart from the commercial challenges, there are some scientific challenges. As I mentioned, due to the insufficient contact issues, there's poor wettability, undesirable solid electrolyte interface growth, and lithium metal penetration, which is called dendrite growth, which leads to cell failure. Around the globe, there are a lot of companies working on solid-state battery. Some are working on semi-solid state, all solid state, and some on both. Looking at some of the key companies with their development, in Asia, Prologium has an operational pilot line in Taiwan. They recently announced, last year announced 46 gigawatt hour factory in France. Samsung SDI has a pilot line in Korea, and they're planning to mass produce solid-state battery by 2027. CATL has also announced plans to mass produce solid-state battery by 2027. Now, looking at Europe, Blue Solutions already has polymer-based semi-solid-state products, and they announced a 25 gigawatt-hour factory in France. No timeline yet. Now, looking at the American market, QuantumScape has always made the noise when it comes to solid state. It is heavily backed by Volkswagen. They have a working prototype, but are looking at other markets as well. Factorial is another interesting one with an operational pilot line for semi-solid state battery. And few weeks ago, they introduced an all-solid state battery in collaboration with Mercedes. No update on timelines yet. So, and Solid Power is also one of the key battery material companies working on sulfide solid electrolytes with good collaboration with SK On, BMW, and others. So, as I mentioned earlier, there's no all solid state battery in production. Semi-solid state is about to start production in China, and a lot of OEMs are doing in-house research. Some are collaborating with startups. Some are doing both. Nobody wants to stay behind. Just looking at some of the timelines by the OEMs, back in 2023, NIO came up with a semi-solid state powered pack by V-Lion. IM Motors this year announced a 130 kilowatt hour battery pack in collaboration with Qinchao. Volkswagen has a prototype planned for 2025. I don't expect that's going to happen. And Toyota, when it comes to solid state, has always made a noise. We expect that the 2027 is going to be a hybrid, most potentially with a semi-solid powered pack. In all solid state, you're going to see most probably a prototype by 2028. BMW, Mercedes, everyone is saying that we might have prototype by 2027, 2028, but no mass production till 2030. So in short, the key takeaway is there are developments happening in solid state battery. Semi-solid state is already commercially available in China, but all the companies semi-solid state companies are also working on all solid state batteries. The key advantage with all solid state, you can have lithium metal that will really help in increasing that energy density push, making it safer and hence higher ranges. So that's all from my side. Happy to thank you and happy to take questions later.